Right, I don't actually see any reason we can't start now. So, like I said, we're using the Universal Render Pipeline. I've created this project. It's a completely empty project, brand new, and all I've done is I've imported my assets and I've set the build settings to WebGL. So everything's set up and should just be able to load this up to itch later on tonight. So the first thing that we're going to work on is we're going to work on our character controller, because that's probably going to be one of the more meaty parts of this. So before we do, we're going to need something that our character's walking on. So I'll add in a plane, I'll centre that, and I'll just bring it down slightly so we can see it in front of our camera. Beautiful. Right, now if we open up our Toony Tiny People, and in the prefabs we already have a player prefab. So I can drag this over, and this is going to be our little character. Look at how nice he looks. Right, currently he does absolutely nothing though. We have the avatar, that was what I was trying to think of before, avatar. That's where it's got the actual humanoid skeletal structure behind it, so animations actually run as if they've been motion captured. Right, so we have that in. Now, what we need to do, we need to create our first script. I'm just going to go ahead and I'm going to create a C# script inside a scripts folder. You'll be able to see how often I mess up as well, and how edited my tutorials actually are. So we're going to create that player script, and we'll load this up. Don't tell me it's crashing on me. What are you doing? Reload that. Alright, so we'll get rid of these comments, just like we always do. And we're going to need a couple of parameters in here. So we're going to need a public float for our speed, and we'll just set that to 5 by default. And we're also going to need the character controller. Let's call that controller. So the reason we're using the character controller is because a lot of the things that take a lot of the time are actually sorted by that. So things like our collisions, we don't need a rigid body on there, it takes care of all that. And it just makes things a little bit easier for moving the character around. So the first thing we'll actually do is we'll just pop back in here and we'll add the character controller onto our player game object. So that's just add component, character controller. And then we can leave all these settings exactly the same. Apart from, I want to just bring up this center box and maybe resize it a little bit. This is going to act as our collider, so we want to try and get this around the player's torso. Bring the height down. That'll do for now. We'll see what happens when we play this later on. So we'll start by collecting that controller. So controller equals get component character controller in the start method. And we'll take care of our movement in its own method. So create a private void movement check, and we'll make sure that we call that inside of our update method. So what do we need in here? Well, we're going to need to gather our horizontal and our vertical inputs, and we're also going to need to make those into a vector3 direction. So we'll add those variables again up at the top. These just need to be private as well. Private float horizontal movement, can't spell, and a private float vertical movement, and then one more vector3 direction. So inside of our movement check, we'll set horizontal movement equal to our input dot get axis raw, And in this one, we're going to be wanting the horizontal movement. Exactly the same for vertical. Vertical movement equals input dot get axis raw vertical. And then we can use those to create our actual vector directional movement. So direction will then equal a new vector3. That's going to take in our horizontal movement for the x, going to take in 0 for the y, and then our vertical movement, that's probably not the best way of saying it, but the vertical movement will actually be the forward and backward. That's going to be our z-axis. And then all we need to do to actually get our character moving is check if our direction's magnitude, so direction dot magnitude, is greater than or equal to 0.1. If it is, we can actually move. Well, we are moving because we have input. So we can set our controller dot move, and then we can pass in our direction multiplied by speed, and then we'll multiply that again by time, delta time, to make it frame rate independent. So that's the basics of our character controller. If we go back to Unity, we can double check that our input's actually working. We throw our player script onto the player, hit play, and we'll see what happens. Oh no, that's brilliant. Tell me that. Oh, there we, game of the year. Telling you, finished. Right, there we go. Right, so we've got basic movement done. So now we can move on to the animation of this, just so we're not just floating around the scene. So we'll create a new folder, call that animations, and then inside there we want to create a new animation controller, and we'll just call that player. Now that'll open up in the animator. Now, like I said earlier, we've already got some animations inside of our Toony Tiny people. So that'll be under mail. So we have a death animation, an idle animation, and a running animation. So all three of these can be dragged in. Obviously our idle is going to be set to default state because we don't want to come in dead or running. And we'll just center these up a little bit. Give ourselves a little bit more room here. Okay, so the first thing we want to do, we want to make some connections. So we want to make sure that idle can lead to run. Run also needs to come back to idle. But then death can be reached by idle and run, but it doesn't go back anywhere. We don't want it to actually return to another state. Told you I'm just checking my notes, just making sure I'm not missing anything stupid here. Okay, so inside of here we're going to need a couple of parameters. So we're going to need a bool for, I'll call that is running, and we're also going to need a trigger for is dead. So we want idle to trigger run when is running is true. So we can get rid of exit time on this transition, add in a condition, and is running is true. Then we can do the same for running to idle, but this time it'll be when is running is false. And then both of the ones going into dead, or the death, if things actually want to go my way, we can set that to a trigger for is dead. So we can actually control these via script, and that'll interact with the animator attached to the player, and we can do all sorts of weird and wonderful things. So let's jump back into our player script, and what are we doing next? Well, first of all, I want to make sure that we can point in the direction that we're moving, because currently we're just floating around facing the camera. And this is, to me anyway, really complicated because I am crap at maths. So just bear with me why I do this for a second. So this is going to take in a float. That's going to be turn smooth time. So that's going to be the amount of time it takes to snap from one direction to the next. And we're going to set that to something really low. So that's going to be 0.1. Next, we just need a private float turn smooth velocity. Okay, so we've got those two variables now. Now, inside of our movement check, when we do our magnitude check, this is where we can actually calculate our player's rotation in three-dimensional space. And like I said, this took me a while to get my head round because I'm really bad at maths, but some of you guys may be actually professionals when it comes to maths. To be fair, I should if I'm a software engineer, but hey-ho. So inside of our magnitude check, if we have a magnitude of greater than 0.1, so we're moving, we can check for our rotation. We don't want to check it if we're not already moving because that's wasted processing time. So we'll set a float, and this is going to be our target angle. Now our target angle is actually going to use the mathf namespace on the class, and we're going to use atan2. Now don't ask me what this does, all I know is this works. So what we need to do, we need to pass into that function our direction.x and also our direction.z, and we want to normalize that. No, we don't. What we want to do is times that by mathf.rad2degree. So that's going to get the rotation and give it to us in a 360 degree. Next, we'll set another float, and this will actually be our angle that we pass into our player's transform. That's going to use our smoothing. So what we want to do, we want to set that equal to mathf.smoothDampAngle. Sounds awful. And this time we're going to pass in our transform. We're going to get the Euler angles, and this is going to be y. We're going to pass in our target angle, followed by a reference to our turn smooth velocity, and then we're also going to pass in the amount of time we want that movement to take. So that's our turn smooth time. I hate maths. And then we can set our transform dot rotation of our player equal to a new quaternion dot Euler, and we're going to pass in 0 on the x. We're going to pass in our angle on the y, so we actually pivot round, and then again 0 on the z. Now if we were to go and play this again, we should see that our character controller will move and rotate to actually point in the direction that is forward for that character. So let's have a gander. Bring this up. And we do, we see, we're turning perfectly and everything's looking good. Right, so now we can actually go in and we can start adding these animations. So the first thing we want to do here is get a private animator anim, and we'll grab that again in our start method. Anim equals get component animator. And underneath, we create a private void animation check. Make sure that we call that in our update as well. the last variable that we're going to want to keep here for our animation is a private bool, and we just want to keep track of whether or not our player is in motion or if they're not. So, what are we doing here? What we can do, we can check if our direction isn't actually 0. So if direction is not equal vector3.0 and we're not already moving, then we want to trigger that is moving animation, the running animation. So we'll set is moving to true, and then anim.setBool. Now setBool takes in a string for the ID, which we set to is running in our animator, and we'll pass in is moving. Or else, if our direction is actually 0, and we are moving, then this is where we want to turn off that running animation. We've stopped moving, but our local reference still thinks we are, so we'll stop it, we'll toggle that back to false, and then everything should be running fine. I think that's everything for me there. So let's have a try, see if this works. So currently we should have, if we pop over to our scene, get our player, and in our animator we can drag in the player controller. We hit play. Let's see if this is working. We should jump in as our idle animation, and we do. Arms by his side, no longer T-pausing. And now when we move around, we have a smooth running animation. It's already looking pretty good. Let's have a look. Is anyone chatting? Why do you create a vector 3 every time? Why am I doing that? We need to create the vector 3 every time for the direction, because the direction is actually going to be updated potentially every frame whenever you're pressing your WASD keys. And yes, I do prefer Visual Studio over VS Code. Even though VS Code's a lot more lightweight, I just find it's a lot more of a pain in the arse to actually set up. Right, so we'll come back to that controller in just a minute. Now we want to make sure that our camera is following our player around, because currently this isn't actually going to pass as a game. We can actually go outside of the camera bounds and we can go and yeet ourselves off the edge. Beautiful. Right, so what we're going to use for this is Cinemachine. Now this is another thing that you can actually get from the Unity Package Manager. It doesn't actually come by default, so if we go to Window Package Manager, and this always takes ages to load for me, I don't know if it's my computer or if it's the actual package manager itself. And we see we have Cinemachine in here. I've already got this installed, I've got it up to date. If you don't, just it'll have either download or install written there. So you can do that, let it fill in, and then we'll get this Cinemachine tab up at the top here. And what we want to do, we want to create a new virtual camera. And it creates a separate game object, but also links our main camera into it using a Cinemachine brain. Now we don't have to do anything with that Cinemachine brain, we just want to mess about with the CMVCam1 that it's created. So we'll pull this back and we'll try and line this up again. Now over here in our Cinemachine virtual camera, we want to drag in a player into the follow field. And then again, I'm going to have to set this up. We just drag that up, drag that out, and then we can aim this down. Really precise, as you can tell. I know exactly what I'm doing. And if we were to run this now, we can always tweak this again. That should actually automatically link up, and it absolutely does not. What is happening there? Beautiful. Ah, that's why. So we need to change, instead of it being lock to target with world up, we need to change it to lock to target on assign. Now that should work, I hope. Let's have a look. There we go, that's a lot better. And like I say, we can actually tweak that. I think that might be a little bit too close. So if we pull it back a little bit and then up, we'll soon find out how this is actually going to work when more stuff's actually dropping in. So far we have a character controller working, we have our animations working, and we have a camera following our player. But we actually need somewhere for him to run around. So I don't know whether or not to do this immediately or keep you waiting in suspense. Now, the first thing that I'm going to do, actually, I'm going to create a wall. Now, our walls are just going to be made up of your bog standard cubes. So let's create a wall there. And again, in my existing assets, I'm going to use the texture pack that I've found. And I have a wall and also a dirt material. So the dirt material I'm just going to throw in on my floor. Simple as that, just drag and drop the actual material itself over into the model. And we can do the same for the brick wall. Simple as that. So now we can actually create a prefab out of this. Let's create another folder. Call that prefabs, and I'll just drag my wall over because we're going to need a good few hundred of these when we actually run the game. So there's two ways that we could actually do this. We could duplicate this and create a map. I don't want to do that because that's going to take way too long. So what I'm going to do, I'm going to create a script to generate the maps for me. And we'll just call this Map Manager for now. Wait for this to open up. Okay, now we've got that. So the way that I actually want to do this, I want to pass in a texture 2D, so just a bog standard image file, and I want to read over the data in that image. If I have a black square, black pixel, I want to spawn in one of our walls. If it's transparent, I want to keep a reference to that so I know for later on in the video that we can actually use that space. There's nothing already there. So let's get to it. The first thing I'm going to want to do is I'm going to want to make this a singleton because I'm going to want to call the map manager from elsewhere in our scripts. So create a public static manager and I'm going to call it instance. And in the awake method, I'm just going to check if instance is equal to null, instance is set to this, or else if we already have one, let's destroy that game object. Right, so let's take a think about what we're going to need in here. We're going to need a public texture 2D array, and these are going to be map images. We're also going to need a private texture 2D for a selected map. We'll just keep a reference to that. And then we're also going to want a public game object, which is going to be a wall prefab. So we can set these up in the inspector in just a second. But what we're going to do, we're going to create a public void generate new map. And we're also going to want to call this in start, not static. So So if we call this in start, then when we start the game, we should automatically get a brand new map. And like I said before, we're going to want to keep a reference to all the open spaces, any space that we have that isn't actually populated with a wall. So that'll be a public list of vector3 positions, and we'll just call that open positions. And we'll initialize that with an empty array. Now the last thing we're going to want to keep track of is our wall color. So this will just be a private color, wall color, and we'll set that equal to color.black. We'll see how that works later on. So what that's going to be, that's just a reference to the pixel color that we want to replace inside of our game scene with the wall prefab. You'll see exactly what I'm getting at in just a minute. This script probably won't take us too long. So inside the generate map, the first things that I want to do is I want to make sure that I clear out the open positions, just so we don't actually get anything from the previous map that we've generated in our new map. Next, we'll set the... Why can't I spell fat fingers? Why can't I find chosen map? Oh, selected map, that's why. Selected map, we'll set that equal to a maps array, and we're going to get a random element from that array. So we'll set that to random.range maps.length. So what that's going to do, that's just going to take one random map out of our array, put it into the selected map, and then we're going to use the selected map to actually build a map. Now we're going to need a couple of nested for loops here. So I'm just going to create 2 for loops. And this first one is going to be for int I while it's less than our selected map dot width. We want to iterate over it. And then the second one, in fact I'm going to name these a little bit better. So that's going to be x not I. And these are going to be y. And in case you haven't already guessed, this is going to be selected map dot height. Now for every one of these, I'm going to call another method, which is going to be private void generate tile. Now generate tile is actually going to take in a couple of parameters. It's going to take in 2 integers, one for the x position that we're at, and another one for the y. And we can go in and generate a tile using the current x and y values from our nested for loops. Now inside generate tile, this is where we want to start reading our texture, our actual sprite map. So we're going to set a color, pixel color, and we're going to set that equal to our selected map dot get pixel, and we're going to pass in x and y. So now pixel color is going to be the pixel color, obviously, of the current pixel that we're reading. And we'll check if pixel color dot a, so the alpha channel, is equal to 0, so it's transparent, we're obviously not really interested in it. I'm just going to add this current position to our open positions array because it can be used later on. So that'll be open positions dot add a new vector3, and we're going to add in, what are we going to add in? I've lost where I'm up to. We're going to add in the current x. Now this is going to be weird, but it's going to be 0 on the y and y in the z parameter. That's probably not the best way of doing it. I'm probably confusing a few people with that, but basically x is going to be horizontal, and then y is going to be our in and out, our actual 3-dimensional movement space. So we also want to return out of that as well, because we're not interested. Once we've set that open position, we can move on to the next pixel. So If it isn't transparent, we'll then just double check if the pixel colour itself is equal to the colour of the wall that we're using to spawn. If it is, we'll instantiate one of our map prefabs. One of our wall prefabs, rather. So we can just do instantiate. Now, you could actually make this a lot more performant if you did object pooling. But I do plan on actually doing a full tutorial on object pooling, so I didn't want to spoil the surprise on that one. And we're going to spawn it in at a new vector 3. The vector 3 is going to be the X, 0 on the Y, because we want to keep this perfectly flat. And then we'll put in the Y on the Z parameter. Probably should have renamed that, what have I done? We're going to pass in the quaternion.identity as the rotation, because we don't want to change the rotation at all. And I'm also going to pass in the current transform as the parent. So now, when one of these spawns, it's actually going to automatically take care of the hierarchy for us, and we won't just end up with hundreds of objects inside the hierarchy. So we have that done. Now, I'll be able to show you this working in just a second, because I don't know if you can hear that, there's a dog walking past outside. He's trying to get on my stream. So I'm going to create a new object. I'm going to call it Map Manager, and I'm going to drag in my Map Manager. Drag in my wall prefab. And now we need to create one of our maps. So I'm going to create this inside of Aseprite. I'm going to do it on a 32 by 32 pixel grid. And I'm just going to make a really simple one for now. We can add more later on. But I know that I'm always going to want a perimeter around my map. So I'm going to create a black square around the entire thing. Then I can just go in and start generating a bit of a map. Now this is probably going to be the worst map you've ever seen, but I need something, and I need something quick. So you can see all of these black squares, all these black rectangles are actually going to be replaced by walls in our game, and all the transparent ones are going to be our open spaces. And I think that should do for now. Yeah, why not? We'll leave it at that. So let's see if this works. Where am I? I'm in Haunted Maze already. Brilliant. Okay, so we'll say this is a PNG, so we actually have that transparency in the background. And I'll call that map 1. That drops in. And I'm going to put these inside my resources folder, just because I want to load these right at the very start when the game loads, and then we'll do that in just a second. So I'm going to throw that into resources, then maps, and then we just need a little bit of setting up on our texture. So we need to leave everything as it is, but under advanced we need to enable read and write, and we also want to set this to point no filter, and we don't want to compress the quality at all. Now, the reason for that is we want to preserve crisp edges, and well, we want to preserve the crisp edges so we can actually read it pixel by pixel without them bleeding into each other and trying to do some sort of anti-aliasing. And you can already see how much space this is going to save of an actual built game, because if we were to generate a full map using our models and then create a prefab out of that map, that's going to run a good few kilobytes. And if we look down here, our entire map is 5.3 kilobytes. So that's quite a bit of space saving right there. And if we drag that map in and hit play, hopefully, fingers crossed, it does work. We're kind of offset, but it works. So if I pause this, show you a little trick that I like to do here. You can see we've generated the full map, which matches perfectly with our Aseprite map. Beautiful. But now what I'm going to do, I'm just going to drag up this floor while we're still in edit mode. While we're still in play mode. Line this up with the edges of our map, and then we'll resize it, because we know that our map is always going to be this size because we're just using a 32 by 32 pixel grid. So we're always going to have 32 by 32 walls. Make sure that we're all lined up here. Doesn't matter about a little bit of overflow, but we can actually just bring that in a little bit. Just like that. Now, if I select my floor plane and copy my transform component, we'll see that everything snapped back where it was. But if we now right click and paste component values, our plane sticks where it should be. And then we can just go and grab our player, move him into an extra space here. So now if we were to play the game again, I don't know what's going to happen now if he's halfway through. Oh, there we go. Now we already have a map, but as we can see, we need to amend our collisions a little bit because I can't fit through that single gap. So let's just quickly go back to our player, zoom in on him. Okay, where are we? So we'll bring in the radius, and let's just double check that again, make sure. Can we fit through this gap now? We can. I think he's a little bit too big though, if I'm being honest, so let's size him down a little bit to 3/4 of his original size, so 0.75 on all three axes of the scale. I think that looks a little bit better. So yeah, we can run around our map. We've automatically got collisions enabled because we're using the character controller that's provided by Unity. So we're already a good chunk of the way through this game. There are a few things that I'm going to do for this map generator though for now. I'm just going to put a couple of placeholders in here. So what else am I going to want in here? Well, I've got my prefab somewhere there. So I'm going to put in a public game object gem prefab. That's going to be the things that we end up collecting throughout the game. And another public game object zombie prefab, and that's pretty obvious what that's going to do. Right, so I'm then going to, I've got the generate tiles, I'm going to create another private void, generate zombies, and I also want another private void, generate gems. So we'll come back and we'll populate those pretty soon. As for that, I think we can leave that for a little bit though now. Getting sore eyes. I went to opticians today and they did that thing where they blow cold air into your eye for check responses or something like that, and I think I'm still a little bit bloodshot. So someone wants to hear my real voice. I don't think you're going to be able to understand me if I spoke in my real voice, but let's give it a go. So next bit that we're going to do, we're going to go on to making gems. So, did you understand that? If you didn't, what I said is, next step, we're going to go into making the gems. So let's have a look how we can do this then. What I'm going to do, I'm just going to quickly rename that to floor as well, so I know exactly what I'm doing. And let's organise these things a little bit. So let's pull that up to the top. I'll put my camera near my camera, and then that down there. Ordering in this doesn't actually make a difference. I just like to be a little bit nitpicky with the ordering I get on this. Okay, so I've already got the gem models. I mentioned that earlier on. Let's have a look at them. So we've got a 5-sided diamond, something that's called a cubie, a Diamondo, and Hexagon. Right. So what I'm going to do, I'm going to make a single prefab that's going to randomly select not only the mesh that's going to be used on it, but it's also going to randomly select a colour as well. Just give everything a little bit more dynamic feel and just make it look a little bit better, basically. So we can drag in a 5-sided diamond, and we can already see that that is huge. So let's rename that to gem. Let's quarter the size of this, maybe a little bit bigger, 0.3. That'll do. Okay, and then we need a material. Now I've already got a plain material in here. Absolutely nothing special about it, just a bog standard grey material, but we're going to override that in the script. We just need that material in there. So what else do we need? Well, we are going to need a collider so we can actually tell whether or not the player's picked it up. And I'm going to use a sphere collider for this. If I can, no, I can actually spell it, sphere collider. And we'll just edit that a little bit. Can I bring that in? Why can't I bring that in? No idea. Just bring the radius in a little bit. And this is going to be a trigger because we don't want it to actually be collidable, but we still want to be able to detect if something's ran into it, i.e. our player. So we've got the basic gem game object for now, anyway, and we're going to need a script for this to actually generate it and take control of the collisions. I'm just going to create a new script, call that gem, and we'll open this up. Exactly, something about foot jams. Toe Jam and Earl, that was a brilliant game, that, wasn't it? Okay, so inside of our gem, what we're going to do, we're going to create an array of meshes, and we'll just call this all gems. And we're also going to create a public array of colours. I'm going to call that all colours. Really gripes me not putting the U in colour, but I think because Unity doesn't already have it, because it's American obviously, it looks kind of odd if I start putting the U in my variable names, but every time I type it I have to take a second not to actually go in with it straight away. Right, enough of me moaning about language differences. So in our start method, this is where we're going to want to get hold of our mesh filter to change the mesh itself into one of our random shapes, and we're also going to want to get a reference to the mesh renderer to change the colour. So we don't actually need to cache these into a variable because we're not going to use them again, we're just going to do the one call. So I'm going to do get component mesh filter, and I'm going to get the mesh, and I'm going to set that equal to all gems, which is our array of meshes, and get a random one of those. So that'll be random.range between 0 and all gems.length. And then exactly the same for the colour, but this time we're going to do get component mesh renderer dot material. That's why we need the material in the from the start, because we'll get a null reference exception there if we didn't have it. And we'll change the colour of that. We'll set that equal to all colours, exactly like we did before, random.range between 0 and all colours, all colours dot length. Oh, it's because I've not put colours up there. There we go. All colours dot length. Right. So now, when our game starts, we should pick a random mesh and also a random colour. And just to save time later, I'm going to add in the private void on trigger enter. And we're going to check if the other, and then we'll compare tag. So if our player is what's collided with it, for now we'll just destroy this game object. So let's see if this is working the way we expect it. We'll take our gem, drag in our gem script, and then we can lock our inspector, And underneath prefab objects that have come with these gems, we can actually get access to the mesh itself, this little grid icon. We select all 4 of those, drag those into our all gems, and then we'll set 5 new colours, and we'll just pick 5 random colours. So we'll have red, we'll have a yellow, we'll have green. We can tweak these whenever we like. We'll also have a blue and a nice pinky purple. Make sure that we pull that opacity all the way up as well. We close that off. Now if I save this and play it, a gem may actually stay as the 5-sided diamond, I don't know. But we should get one of our random colours and potentially a new random shape as well. And we do. So it's decided on red, and it's also spawned in the middle of a wall. That's not good for anyone, is it? See if I move this back and down a little bit, because I want to check that collision's actually working. Right, so I've not tagged my player. So we'll go to our player. We can set a tag to be player, which is one of the default tags that comes with any new Unity project. Let's have a try again. And there we go. We can collide with it and we pick it up. Doesn't affect us in the slightest. So let's drag that gem down into the prefab. Prefab variant, because that was already prefab. Okay, so we have that. Now we can go back into our map manager, and now that we've got them, we can actually go in and we can generate our gems randomly when we generate the map. So inside generate gems, I'm going to want to call that in start after we've generated the map, because generate map is going to add in our open positions, and we're going to use these open positions to pick random places for these gems to actually spawn in. So how many do we want? I'm going to say 5. So do another for loop. We'll iterate over it 5 times, and what we're going to do, we are going to get an int, which we'll call our index, and we'll set this to random.range between 0 and open positions.count. Now it's .count this time because it's a list. And the reason we have to do that is because we want to use that index in 2 places. If we were to just get a random object as we spawn it in, we lose that reference. So I'm just going to keep hold of that, instantiate one of our gems, so our gem prefab, and I'm going to instantiate it at open positions index, and then use quaternion.identity. I don't think I've ever used anything other than quaternion.identity for an instantiate. Could be wrong, could be talking at my arse, but right, so now what we're going to do is we're going to instantiate that at a random position on the map that we know isn't populated by any walls or anything else. But then now we have something in that spot, so we want to remove that from our open positions list. So we'll do open positions dot remove at, and this will take in an index, which will be our index. So we use the position and then we remove it from the list so we can't use it again. So we can see if this works, we can then get rid of that gem from there, go into our map manager and drag in our gem prefab into our open space for it. Let's have a see if this works. We should get 5 random gems scattered throughout open places on the map, and we do. 3 have bunched quite closely together. We have another one there, and where's my 5th one? There it is. I think what's missing for this gem is a little bit of animation, actually. A little spin and bobbing animation. So I will quickly create an animation for this. So I drag that back in, click our animation tab down at the bottom and create one for the gems. Inside our animation folder, save a gem rotation. And if we click the record button, we can just amend our, our object inside the scene view, and it'll pick it up inside the animator. So we'll add in a reference to the rotation. Now we want that to be 0, and then right at the very end, or just, yeah, the very end, the last one, I'm going to, is it X? Yeah. I'm going to set the Y to 359 degrees. And then stop the recording. So now, in the space of one animation cycle, we should spin around 359 degrees, and then when that loops and goes back to the start, we go back to 360 or 0. So let's have a look. And we do, but what we can do, we can just grab our curves here and make that so it's a continuous movement and not a little bit choppy like it is. We do Control A, select everything. Am I in curves? I'm in curves. Why are you not letting me do what I want? There we go. So we right click on one of our little anchor points, both tangents, and we'll set that to linear for both. Now if we were to play that animation again, we see spinning perfectly. What we could do, we can just take that down to 30 samples. So we actually rotate a little bit slower. And I think a little bit of bobbing as well. So let's add in the transform position. Back to our dope sheet. And where are we? Turn on record again. And then when we're halfway through the animation, I want to raise the transform up a little bit, and then it'll go back down and then start bobbing up and down. Let's have a look. And it does. Beautiful. Beautiful. And I think that should be it. I should just be able to attach that animator to my prefab. Where is it? Added component. No, I don't want to override it. Tell you what I'll do. I'll completely break it out of its prefab. Delete the prefab. And then drag that back into the prefabs. I'm saying prefab quite a lot there. And then we need to drag that back into our map generator. Let's have another look. Why do we have two in the same space? Why do we have all of them in the same space? What did I do wrong? I know what I've done. Because we've actually added a animation for the position, that set it to this position where it is now. So it's expecting it to be exactly there. So what we can do, we can just create an empty game object. I'm going to call this gem. Unpack that. And then put our gem variant as a child of gem at 0, 0, 0. So now if we make that our prefab, the animation on gem variant, the child, is still going to bob up and down, and it's still going to be at its 0 position. I think. Let's double check. No, that's moved it back. Right, I'm going to need to just amend this really quickly. So 0, 0, 0. Bring that in. Bring that back. I knew there was something I was missing there. So we'll just bring that in. So now we spin on the spot, and this one is where we want to go up a little bit. So now we're bobbing up and down like we were before. Drag our gem parent in as the prefab, and then finally in the map manager drag our gem back into there. Now they should be scattered around again, hopefully. And that looks a lot better now, doesn't it? Somebody tell me that they like what I'm doing. Is everyone still here? Oh, I've still got people in. I'm surprised you've not got bored of me already. Right, let's just take a little water break now. My eyes are glazing over again. What are people saying? What are you talking about? The maze won't be infinite, but we are going to create a few more actual designs. Tell you what, we can do that now, so I can actually show you what this does. So if we delete everything from the inside of that, and then leave our border, we can then just draw in whatever we like. I tried a sample map when I was practicing this a couple of days ago, and it was an absolute nightmare. And the reason it was a nightmare is I did something like this, and it just made it hell to navigate around. But we'll soon find out, won't we? So we can just create anything that we want in here, as long as we only draw in black. The map will just completely generate, the map will just completely generate around it. So let's save that. So we can save this again as a PNG. Save that as map 2. That's going to be in resources maps. Save that. And then inside of our map manager, well, first thing we need to amend it again like we did with map 1. We need to make sure that we set read and write to enabled. So bilinear, no quality loss, and want to enable read and write. And then we can go ahead and drag map 2 into our maps array. So now there should be a 50-50 shot whether or not we get our original map. In fact, what I'm going to do, I'm just going to unmaximize that so we can have a float around in the scene view. So I think, is this that's our original map. Okay, so we have an original map and the 5 gems are spawning. Let's see if we can get a new map. There we go. And as you can see, we've got 5 gems spawning in open spaces on the map. And we can go and have a walk around. And yeah, this kind of map is a nightmare to navigate around. But yeah, whatever. We know what we're doing. Right, so really quickly what I'm going to do, I'm going to start adding in some audio, just because it makes it feel a little bit better when you've got a bit of sound playing in the background. So where are we? First thing I'm going to do, I'm going to add in the gem. So that's going to be a public... no, not the gem. No, we'll come back to the gem. We'll do the player first. So we'll add in an audio source for our footsteps. What was that? Hey, you got a subscriber. Hey. Hello. I've lost what I'm doing now. I got excited then. Right, so we have audio for our footsteps. So, where am I putting that? Let's wing it. Right, so when we're moving, we obviously want to play that. So when we start moving, we want our footsteps dot play. We want to call that, and then when we stop moving, footsteps dot stop. I think that should be it for our player's footsteps. My computer's running really slow because I've got this stream running at the same time as well. I don't think it's worked this hard in years. Okay, so then we can go to player, add in an audio source, drag it into our script, and then in the audio clip we want the running sound effect. We want that to loop. We don't want it to play on awake, and we may want to affect the volume, but let's just have a check. So I don't know if you can hear that. We have footsteps now. Now the reason I've said that we'll come back to the gem is because we destroy the gem, we can't actually play a sound from it because the audio source is going to be destroyed. So what I'm going to go ahead and do is I'm going to create a little audio manager and also a script for this audio manager. And the reason for this is any sound effect that we want to play and then we want to destroy or remove that object, we can still play it in the audio manager and get rid of it, get rid of the game object, and then the sound will still play. Let's create this audio manager really quickly. It's only going to take a few minutes to do this one. Whenever it wants to load. Gotta stay hydrated. Did I even click that? Oh, there we go. Right, so again we're going to want this to be a singleton. So public static audio manager instance, and then in the awake method, if instance equals null, why can't I spell? Instance equals this, or else we'll destroy that game object again. Standard singleton behavior. So audio manager is going to need a public audio source, and we'll call that SFX for sound effects, and we'll also add in another audio source for ambient music. We may not actually need that because we're going to keep that ambient music running throughout. If we don't, we'll remove it later. But the only thing that we want is we want a public, what do we want? It's going to be a void, and we want to play a sound effect. Now this is going to take in a parameter of an audio clip, call that clip, and then really simple, we'll do sfx dot play one shot, and we'll pass in the clip. Simple as that. So now back to our gem script. If we add in a public audio clip this time, call that pickup sfx, and before we destroy the gem, when we collide with it and we pick it up, we'll call audio manager dot instance dot play sound effect, and we'll pass in our pickup sound effect. So that should work. Now I may be wrong, it may not work. Let's have a look. We'll open up our gem prefab, gem variant, down to our gem script, and we'll add in the gem pickup to our audio clip. Now let's have a look if this plays a little twinkling sound when I pick up a gem. Absolutely not. What have I done wrong? I'm getting in a reference exception here. What have I not set? I haven't put my audio manager in the scene. That's why. Drag that audio manager in. Need to set this up as well. So audio source and another audio source. The first one is going to be our sound effect. The second is going to be our ambient music. So we can just drag in our ambient music to the second one. We want to play that on awake. We want to loop it. And I think this is the one that I've actually got to take the volume down because it's ridiculously loud. Let's have a go. Let's see if this works. Here we go. If you can hear it. Can you hear it? Some little eerie ambient music, and then hopefully there we go, a little ding when we pick up a gem. There we go, everything's looking right. There we go. So what else have we got to do now then? We still need our zombies, but I'm leaving that to the end because that's the pain in the arse bit, trying to deal with the... we're only doing basic AI, by the way. We're not doing anything super intelligent. But yeah, we'll get to that. Hey. Should we do the zombies? Should we do the zombies now? I'm just going to nip off 2 seconds. You let me know in the comments if you want me to do the zombies now or do the UI next. Just be 2 minutes. Are we back? Zombies, please. Zombies with AI. Here we go. Okay. Zombie time. So the zombies are going to be a little bit similar to our player. Whereas we're going to have a pre-done model, pre-done animations. We're going to create that animator again for our zombies. Then when we have all that in, I'll get into the dreaded AI. Right, so let's start up. Let's start with this. Let's drag that audio manager up a little bit. Right. Zombie. Existing assets. Tiny, toony, tiny people, whatever it's called. And I'm going to drag in my zombie prefab. Bring him over. I think he might be a bit big as well, so we'll add 0.75 onto him. Okay, here we go. I'm doing it. I'm not nervous. You're nervous. Don't tell me I'm nervous. Right, so the first thing we're going to need is a capsule collider, just like we had with the gem. And it's going to be a trigger, and then we'll edit this. Bring him up. Add in some height. Offset that. Looks about right, and then we'll bring in the radius to be the size of the body like we did with the player. Yeah, I've already set that to trigger, so that's fine. We'll also create an audio source on this as well, because our zombie is going to emit a sound when we are within range. I should probably explain how I actually plan on doing this, shouldn't I? Just drag that clip in. Don't want to play on a wig, don't want to loop. Okay. So the way that I want to work this is the zombies are going to be walking around our map idly. They're going to pick a random spot and they're going to try and walk to it. If our player comes within a certain range of the zombie, they're going to take interest and they're going to chase after the player. If the player manages to get so far away from the zombie, then it's going to lose interest and continue just idly walking around the map. If the zombie touches the player, that's it. I'm not doing a health system or anything like that. You get one chance. We're going old school here. Dark Souls rules. You die, you die. Okay. Not looking forward to doing this. Hated doing this when I did the practice run as well. What are people talking about? Hello, J Jack. You still here? I hope you're still here. We're having fun. We've done an hour and 20 minutes, and have you seen how far we've got? We've pretty much got a full polished game. Right. I'm just trying to distract myself. Right. So what we're going to do, we're going to use the nav mesh. And we're going to want to put the nav mesh, or the actual mesh itself, on our floor. Now we're going to want to put that on the floor. We're going to want a zombie to be able to move around that. But we're also going to want to avoid any walls, which is going to be slightly more complicated, not much, but because they're randomly spawned in, we want to cut out little bits of the map so zombies don't actually go running head first into a wall. So the first thing we want to do, we want to select our floor layer, or our floor object, and we want to add in a nav mesh surface. And if we just click on that and click bake, we should see everything turns blue. But first problem that we see, it's taking into consideration our player and zombies. And we don't want that. We want this to be a entirely walkable surface. Now there's an easy way of getting around this, and that's just by ignoring a layer that these objects are on. So if I just select my player, go up here to layers, and add a layer, I'm just going to call this movable, because it's a movable object. Select both our zombie and our player, and we're also going to want to do this for the gem as well. We'll add that to that. Now if we select the floor again and rebake, it's not going to do anything because I haven't selected the layer. So under the include layers drop down, we'll uncheck movable. Click bake, and now our player and our zombie and subsequently our gem is going to be completely ignored from the nav mesh. What we do want to do, we want to amend our wall prefab, and this is going to be a nav mesh obstacle. Now when we play the game, we want these walls to carve out a section of this nav mesh so the zombies can't walk on it. So we'll add in onto the prefab a nav mesh obstacle. Luckily we have a box, so we can leave it as a box. Everything's perfectly sized around it. The only thing that we need to change is we need to check curve and make sure that curve only stationary is still checked. So what that's going to do, when this spawns in, it's going to regenerate the nav mesh underneath, and that's going to cut out the walls. And we'll be able to see this if we go into the scene view, play the game, and we select our floor. So we can see that our walls have actually completely chipped away at our nav mesh floor. So now our zombie should be able to move around on anything in this map that is blue. Perfect. Just having a check of what's going on in the chat, making sure everyone's having fun. Everyone's having fun. Everyone's talking about Flux and no idea what Flux is. Alright, I need to stop getting distracted by. I knew that was going to happen. I always get distracted by little things like that. So I just keep going over, and then I completely forget that I'm on live stream and I'm just reading the chats going, oh yeah, oh shit. Right, so where are we up to? We've baked it. We have it ignoring the walls. Now we want the zombie itself to walk around on it. So we'll select our zombie object. We'll add in a nav mesh agent. Now that's something that can move around on the nav mesh. And then we get a couple of settings here. So we've got the steering settings, which are all your speeds, the acceleration, stopping distance, blah blah blah. So we'll set speed to be 3 for now, I think. And everything else we can just leave as is. So currently, if we were to play the game, nothing would actually happen yet because we've not actually given any commands to that NavMesh agent. We're going to need to create our zombie script before we can get it moving. So we'll do that first, and then we'll create the animations for the zombie as well, just because that's not difficult, it's just a little bit time consuming. So let's create a new zombie script, and we can open this up in Visual Studio. I'm doing it again, I'm just reading the chat. Right, so we'll just get rid of the starting update for now, and we don't need system namespaces, but because we're using the NavMesh components, we're going to need to be using UnityEngine.ai. And AI is probably going to be used very loosely in here, but we'll get on with it. So there's a few variables that we're going to need. We're going to need a private vector3 random position, and that's going to be the random position when the zombie isn't chasing us that we're going to want to walk towards. Next, we're going to want a target position, which is going to be a game object, which is just going to be set to our player from the start. So our zombies are always going to know where our player is, but we're not going to chase the player down until they get too close. So that's going to be private game object target. We're also going to want a reference to the NavMesh agent that we just assigned to the zombie itself. So that's private NavMesh agent, call that agent, and we don't want to do anything with the animator just yet, so we'll leave that one. And we'll also just set up audio source as well, and that's going to be a groan sound effect. So when we get within range of the zombie, it's going to let out a groan to let the player know that one of the zombies is now chasing him. So let's start with our start method. So we're going to set random position equal to our current position, just so we have something in there. Okay. Next, our target position, or our target, is going to be equal to GameObject.find GameObject with tag, and we're going to find our player. So like I said, we're always going to have a reference to where our player is, but we're not going to do anything about it until we get too close. Next, our agent is equal to getComponent NavMesh agent. And that should be it for now in our start method, I think. So let's move on to our update. I think this may be the first update method I have in this game. That's actually pretty good going. Right, so this is where we're going to want to keep a track, or keep check on our distance between the current zombie that this is attached to and our player. So we want to check the distance between those two objects. If it's closer than a certain amount, we'll trigger the following sequence, or if it breaks apart from that, we'll lose the player and we'll start walking to a random position again. The way we can do that, we can check if vector3.distance, and we'll pass in the current transform.position, so our zombie's current position, and our target.transform.position. So if the distance between those two transforms is less than or equal to 5, then we're within range. So this is where we want to chase the player. Or else, if... Yeah, I'm missing something there. I need a boolean. Private bool is running. So this will be whether or not we're actually being pursued by one of the zombies. So if we're already running, then this is where we want to then break the chase. Is that right? Vector3 distance between that is fine, or else... Yeah, so if we're too close, we're going to start chasing. If we're not too close and we're running, we want to break that chase. Yeah. Is that right? Yeah, and we also want to keep track of whether or not we're idling, walking about. So we'll keep a is walking boolean there as well. So the first thing we'll run on is the run after player. So we'll create a private void chase player, and we want to call that inside of our distance check. What's going on in the chat? People are having good conversations in here, I love it. Right, so in the run after player, what we're going to do, we're going to get our agent and we're going to set a new destination for it. So we'll do agent dot set destination. This is really easy. The nav mesh thing itself, I know I was joking about it before, but the nav mesh system itself is really simple to use. It can just be a little bit finicky when you're just starting out with it and you don't really know what's going on. I know it was for me. Right, so we want to set the target destination for our enemy to be the transform.position of our player. So that's going to constantly update, so we're just going to give chase on the player. And if we're not already running, then we want to just set up a few variables inside here. We want to make sure that our groan sound effect plays. We want to set is running equal to true. We want to set is walking equal to false. Now that is running and is walking. The reason I didn't put those in straight away is because I forgot that I was going to be needing them at this point. But these are actually going to be used primarily inside of our animator as well. So, what have we got? We play the groan. We set is running to true. Is walking to false. We start chasing the player. We'll set the speed equal to 2. We'll change the speed so we start running a little bit faster. And then here we can trigger our animations for it. Next we'll do the break from the player, so this will be where we start walking to a new random position. So here we can do a private void walk to random spot, and we'll call that inside here. And also when we actually reach that spot, we want to make sure that we pick a new spot, so we don't walk there and then our character just stands still, does absolutely nothing. So the way that we can actually do that is, how do we want to do that? How do we want to do that? Tell you what we can do. We can just set, if we're walking, so walking is going to be the idle walking to a random position. So if we are walking, and then if vector3 dot distance between the current position, so our transform dot position, and the random position that we've selected is less than or equal to 1. So if we get so close to the random position, then we'll just pick a new one, which means we can just actually call walk to random spot again, and then we'll just take care of that. We'll change the random spot. I think that'll work. Yeah, I'm sure that's how I did it. Right, I'm just mumbling to myself, sorry. Right, so if we are walking, we'll set our agent's speed to something lower than 2, so we'll set that to 0.75. We can always tweak these later on. So we're going to walk slower than we're running, as you'd expect. We'll set the random position. Now the random position is going to need to come from a map manager. So let's create a little public method in here. We'll return a vector3, and we'll just return a random position. What did I call my? So we only want to spawn, we only want to pick open spaces for our zombies to move to. We're going to return open positions, random.range 0, open positions dot. It's not count because it's a list. So now in our zombie, we can call map manager dot instance dot get random position. So that's going to just bring in a random position from that list of vector 3s inside of our open spaces. And now the zombies are good. Well, this zombie, it's going to be a random selection for each one of the zombies. But this one is now going to try and walk towards that position. So the way that we can do that, like we did before, we set agent.set destination, and we want to set that destination to be our random position. Next we'll set is running equal false, is walking is equal to true, and then do our animations inside there. So let's just have a quick read over this, make sure that we have everything in place. So the start, we pick the random position, which is itself. The target, we grab the player. The agent, we just grab a reference to the agent. Then in the update, we check if the distance between our current position and the player's position is less than or equal to 5. If it is, we'll chase the player, which sets the destination to be the player's current position. And if we're not already running, we just set all our animations up and everything like that. Now that'll keep looping while we're within 5. Else if we break out of this, so we become greater than 5 and we are running, then we'll walk to random spot, and then in walk to random spot I set is running to false, so then this should only trigger once. And we also set is walking to true, so then this will start triggering. And if our distance between our random position and our current position is less than 1, we'll pick a completely new random spot. Hope I have that right. Now we should be able to actually drag in our zombie script to our zombie prefab. That'll go away. Break that out of that, and then hey prefabs. Drag the zombie over. Drag in a groan sound effect. Now let's see if this works. Ooh. Right, so he's chasing me. He's running after me pretty bloody quickly. Now if I break that, we can see over in the scene view he's lost interest. He's picked a random position on the map and he's slowly making his way towards that. If I get too close, he groans again and begins chasing. So that is pretty much our AI. I know it's not much, but I did say that it was going to be really basic AI. But he knows to avoid walls. He knows that he needs to chase the player. We can also break the line of sight to the player. And he's also going to randomly walk around. And if we left him long enough, he'd reach his point, his random point, and then he'd pick a completely new one, and he'd be continuously walking around aimlessly. Sounds like me on a standard day. Right. So now we have that. We can create a prefab out of our zombie, because we want to generate more than one of these. We can delete our zombie, and inside of our map manager, drag our zombie prefab over into the zombie prefab section. Pretty simple. Why wouldn't you do that? Okay, so now we can go over to the generate zombies inside of our map manager, and that's going to be pretty much exactly the same as our generate gems. We want to call that inside of our start method, and instead of instantiating a gem prefab, what we're going to do, we're just going to instantiate a zombie prefab. So that'll put 5 random zombies in there. We can add a couple to that. Maybe try 7. Let's have a look. So yeah, if we play the game again, we should now have 7 random zombies, 5 random gems, and our player. And we do. Ooh, got a little bit close to one there. Oh. And currently nothing happens. We want to kill the player. And we want to do that inside of player script. We can do a private on trigger enter. Sorry, my eyes are getting a little bit sleepy here. Just bear with me. Let's check the chat. Let's have a second again. Let's take a break. It's always important to take some breaks when you're working. Keep your eyes from completely glazing over and gathering dust. What's everyone talking about? Are we having fun? I think I've collared J-Jack. I'm sure he said he was only going to be here for a couple of minutes, and he's still hovering around. Everyone's just having the little conversations. Bear with me. Smoking's bad for you. Don't do it. Okay. So let's work on killing the player, because we don't like our player. We'll kill him. So inside of the on trigger enter, we want to check if the other.compare tag, so if we collide with a zombie, first of all we want to actually set our animation. So anim.set trigger, because we had this as a trigger, and the trigger name that we set is dead, I think. So we can actually just double check that this is all completely up and running fine if we open up the zombie prefab and tag this as zombie. There we go. I think that should be fine. Now, if we come into contact with a zombie, we should play a death animation. Let's see if this is working fine. There we go, and down he goes. But we can still skim around the map, so we just need a way to actually stop that from happening. So I'm just going to create a quick public, no, it could be private, bool can move, and we'll set that to true by default. We will do movement and animation checks if we can move. So we'll just wrap those inside of our if statement. Oops. Wrap those inside of our if statement, and when we die, we'll set can move to false. So that should get rid of that weird glitch where we can move around while dead. So why did I press it again? I pressed it again. What did I do that for? You tell me. Right, so we can run around. I don't remember this map. How did I design this map? Grab that, grab that, grab that. Oh, there we go. Right, so we go down and, yeah, can't move anymore. Beautiful. We'll have the sound effect as well, actually. We'll do that through the audio manager while we can. Add in a public audio clip, scream sound effect, and when we die, we will call the audio manager .instance .play sound effect and pass in that scream. To the player, and we should have the player death sound effect. So now when we die, we should let out a blood curdling scream as well. Let's have a go. We're out. There we go. That wasn't the sound effect that I remembered it be. But it works. If it works, it works. Right, so now I'm just going to quickly work on the zombies animations. So I need to create a new animation controller. Call that zombie. And then inside here, remember we already have our animations from this pack that we're using. We can drag in all 4 of those. So we've got attack, idle, run and walk. So our idle is going to be our default state. And then how do we want to go about doing this? So we'll set our run and our walk on the sides and have the attack down at the bottom. So we're going to be able to go to and from idle and run, to and from walk and idle, to and from idle and attack. We also want to be able to attack and run to walk. That's an important one. So basically everything can go to everything else. Is that right? Yeah. Right, so we'll add our parameters in. So we've got a is walking boolean, we want is running, and we also want another trigger for attack. So we'll quickly go through all of these. So idle to run, get rid of exit time. We don't want exit time on anything that isn't a returning animation from a trigger. Now that'll make more sense in just a sec. So we want idle to run if is running is true and is walking is false. We want to go from running to idle if is running is false and walking is also false. And get rid of that exit time again. The reason we get rid of the exit time is because we want these animations to actually trigger immediately. We don't want the previous animation to partially finish what it's doing before it merges in. If we did that, it'd just look really choppy. So we just get rid of that has exit time. Our animations will trigger straight away. So now idle to walk. Is walking is true, and make sure that is running is false. Walk to idle is walking and is running equals false. Next we'll do walk to run. This is really boring. I don't blame anyone who drops out on me at this point. I'm being serious. Okay, so we want walk to run is running is true, is walking is false, and then the opposite. We want exactly the opposite to that. So we want is walking is true, is running as false. Next we want the attack animation. So if we're running and the attack trigger happens, we'll go into the Z attack, and then we'll just, this is the one that needs exit time because we don't actually have a parameter, because a trigger will just trigger once, it'll trigger Z attack once, and then it'll take itself back to where it needs to go. Now this one does need exit time because we're not adding in a condition. So that'll be the same for the other attack exit states. So now walk to attack, again that's just going to be is walking is true, and we have an attack. I think actually I need is running true, an attack on that one. Next we'll leave that as exit time. Idle to attack, we want is walking false, is running false, and attack. Then the next we just leave as it is. Just for safety, I'm going to add in the is running to these attack animations as well, and is walking false, just so we don't end up with any crossed wires. So let's jump back into our zombie and we'll set these animations up and running. So if we're not already running, what I want to do, I want to set anim. I've not actually got the reference to the animator in this. Private animator anim. And then in here we'll do anim equals get component animator. One thing we do want as well, we want to make sure that we walk to a random position when we start. So walk to a random spot in the start as well. Right. So first things first, we'll add in our attack animation as well. So we'll check the distance between our player and our actual current position. So if vector3.distance between transform.position and the target, so our player.transform.position, if that is less than or equal to 1, then we want to attack. Now we don't need to see we've actually got the hit on that because we're using the collider for that. So all we need to do is just set the animation trigger. So anim.set trigger attack. So if we get too close to a zombie, it's going to swing for us. Next, we want to make sure that we set is walking and is running booleans to what they should be. So anim.setBool is running, and we'll set that to a local instance of is running. I'm just going to take a copy of that, and we'll change is walking equal to is walking, and we need to do that again inside there. So now we should actually have some sort of animation on our zombie. We'll just have to connect this animator up in the prefab. Do we have an animator? We have an animator attached. So I'll go ahead and drag my zombie controller in there. Save the project and let's have a go. So we can run around. Our zombies are walking, our zombies chase and run. If we break, they start walking again and he's picked a random spot. There's another guy. If we get too close, you see they swing for me. And then I die if I get too close. So there's not actually that much left that we need to do on this. We need to keep track of our gems. And we need to pop up some UI whether or not we die or if we win. And I think that's it. Told you it was going to be a basic game. How long have we been going? Just under 2 hours. We've made pretty much an entire game, albeit a very simple game, in 2 hours, while I've been trying to keep up conversation as well. And my throat is very sore. I don't know why people do these streams that go on for 12 hours. Must just be practice. Would you like my hoodie as well? Forgot to show you that. Got a nice little custom hoodie going on. Okay, so what did I say we needed? Need a UI. We'll start with the UI first, that's going to be the easiest way, and then we can actually keep a reference to other things. So I'll throw in a panel on my UI, rename that. UI. Game over. How do I look here actually? I'm leaning forward. Do I look stupid? No, I look alright. Right, we'll scale this down. That kiss was to me missus anyway. I know she's still watching. I can hear myself on an echo downstairs. Right, so we'll drag in that. Make it black. Make it slightly more opaque. And then I have a little header image for this as well. So I'll add an image in, go into my UI, UI top, and set that to native size. Just so it adds a little bit extra to the UI here. So we'll scale that in and pull that up to the top here. I want to make sure that we anchor that to the top. Rename that. So what do we want inside here? Well, we're going to want Text Mesh Pro element, and I already have a font as well, a nice looking horror font. So we drag that over. Ooh, beautiful. Ooh, beautiful. Game over. And we'll put that about here. Disable wrapping, so it'll all stay on one line. Drag it down. Next, we're going to want a bit of text for whether or not we won or if we lost. So we'll add in another Text Mesh Pro. Add that in. You win/lose. We'll amend that in script later on. And just make that a little bit smaller. And drag that up. And then finally, we're going to want a button that'll just reset the entire thing and give us a new map again. So add that in. Play again. Drag that in, and this font is actually a little bit too high. Let's drag that down. Now, this is probably the only thing that I didn't actually get an asset for, sadly, but we're going to have to deal with a plain button. But we'll just give it a nice dark red and make the font bright white. Simple's always good. So now we have our UI, so we need a UI controller. That's one more script that we need. Connect this really quickly, and then we'll call this game over screen whenever we either collect all 5 of the gems or if a zombie touches us. So again, this is going to be another singleton, so public static UI manager instance away if instance equals null, instance equals this, else destroy the game object. Start. We want to make sure that game over menu's not visible from the start, so we'll create a public reference to that. It's just a game object for these UI elements. Public game object, game over screen, game over, and then we want to make sure that game over is not set to active at the start, so set active is false. Next, we also want a Text Mesh Pro element for our win or lose text. So that's going to be using TM Pro. Public Text Mesh Pro UGUI. Win lose text. And we'll create a public void show game over. And we also want one for the button as well. So public void play. And we're going to want to reload the scene completely when we want to play again. So we'll use Unity Engine dot scene management, and inside here all we need to do for the play again, we just call scene manager dot load scene 0, which is going to be our only scene, our main scene, the one that we've been working on this entire time. It always lags when I try and do load scene, and I have no idea why. Anyway, right, so show game over, we want this to trigger in 2 different states. So we want it one state if we win and one state if we lose. So we'll pass in a boolean and we'll just call that isWin. So if we have one, so if isWin, win lose text dot text will be equal to you won, else. In fact, we can actually use a ternary operator on this to make it a little bit nicer. So win lose text dot text is equal to is win question mark you won or else. you lost. Simple. Gets rid of an if-else statement and perfectly readable, perfectly fine. We actually don't need the brackets on that as well. Beautiful. Yeah, so when we actually show the game over menu, we want to make sure that we show the game over menu. So we'll set that active. So we'll set that active to true. And that should be it. So now in our player, we can call UIManager.instance.showGameOver with false there because we died, we didn't win, so we want to make sure that we put the you lose message up. And when we collect all 5 gems, we want to call showGameOver menu, but again, we want that to be you win this time. So let's just go in and we'll set this up. So on our canvas, first things first, this is going to mess up my scaling, but I forgot to do it. We need to change this to scale with screen size. And yep, it completely screws over my scaling. So I'll just bring these up again a little bit. The reason you want to do that is because if you start using these on other devices with other aspect ratios, people with bigger monitors than you, whatever, it's actually going to keep everything in the same space. We're not going to be scaling things weirdly for different people. So when you lose, you win some, you lose some, baby. Why did I do that? I'm on a live stream. Right. Drag that down. Why didn't that move down in my game view? Oh, it did. I have no idea what I'm doing. Right. So in our UI, we'll drag in our UI manager. We want to drag in our game over game object into our script. And we also want to drag in our win or lose text into our win-lose text field. Now when we start, this will be set active, well, won't be set active, it'll be set active false. And it is, and then if we die, oh, it doesn't do it. Why doesn't it do it? It should do it. What have I done wrong? If anybody knows what I've done wrong, please tell me. Instant show game over, false. That should work. I've got it attached, it's in there. Does anybody know what I'm doing? Is that text mesh text in the button? Yeah, it is. It's you can spawn in a Text Mesh Pro button, which is just a standard button, but with Text Mesh Pro text. Oh, what have I done wrong there? See, I thought I was can't even speak now. I was dreading this bit. Something goes wrong, and now I've got to try and debug it while people are watching me. That's never a good thing. Never a good feeling. Right. So we have an instance. We're setting this. If instance equal null, yeah. So we've got the game over menu. Game over menu set active true. Play UI manager instance show game over false. So all this triggers though, so why isn't that triggering? I've still got my UI there. Ah, I know why. I'm setting everything inactive, aren't I? That's set into inactive. Nah, I'm using game object set inactive. It's not that. It's game over set active false. That's why I was setting the actual canvas itself to inactive, so nothing could actually be called on it. Now this should work. When I say it should work, it should pop up with my game over screen with you lose on it. And it does. So if I just link up that button there by adding an on-click event, dragging in my UI canvas, UI manager, play again. And then if I try this one more time, then we'll just get onto the final little bit where it's collecting the actual gems. Ooh. Zombie spawned right on top of me. I should probably fix that. If I click play again, we spawn a new map, die, play again, spawn a new map. Right, the final thing, probably going to be less than half an hour this. I think we've done good here. We've done 2 hours, 5 minutes, and we've almost finished our game. It's not going to win any Game of the Year awards, but it's a game. And it's better than recreating Flappy Birds for the 900th time on YouTube. Right, so what do we want to do? How do we want to do this? Can I do it in Map Manager? I can. See what I'll do. Inside of the Map Manager, because it is technically part of the map itself, so I don't have to create another script as well. What we can do, we can put a private int gems remaining. We'll set gems remaining inside of our generate gems, and we'll set that equal to 5 because that's how many gems we have on the map. And then public void gem picked up, gems remaining minus minus. If gems remaining equals 0, then we can call UI manager dot instance dot show game over with true, which is about right, isn't it? So if we collect all 5 gems, in fact, do that in here. So when we pick up the gem, we can call map manager dot instance dot gem picked up. That's going to trigger this. That's going to check. It's going to take one away, so then we'll have 4, 3, 2, 1. When we pick up the last gem, it'll equal 0, and we'll show the game over menu with the U1 message. Easy. Can't be that easy. One thing we do want as well, we want to make sure that we stop the zombies moving, because if we collect all 5 gems and a zombie walks over to us while we've got a you win message up, it'll still kill us, and that'll replace it with the you lose, but you've already won, so you shouldn't be able to do that. So I'm going to create a public bool zombies can move. I'm going to set that to true by default. If we win, I'm going to set zombies can move equals false, and then inside of our zombie script, I only want to do any of this if map manager dot instance dot zombies can move. It's getting a little bit messy this now, isn't it? I'm trying to rush this out so we don't go into 3 hours of streaming. Right, so map manager, zombies can move is false whenever we've collected all the gems. We can only move if that's set to true. Right, so that looks like that should work. So now we have a winning state. I think that's it. You know, I think we've done. Let's just try. Hey, hello. Oh, avoidance tactics here, come on. Right, so let's try and collect all these gems. I need him to move out my way. Come on, come on. Yes. No. It's actually a pretty good game, if I do say so myself. Whoa! Nearly. Right, come on. Game over, you won. I can still move, but that doesn't matter. And the zombies aren't affecting me anymore while I've got that on. I can play again. We carry on going. You know what? We're done. We've created a full game in about 2 hours. Tell me that's not good. Can I get a congratulations in the chat? Can get a Mike? You made a game in 2 hours. It's crap, but you did it. Like I said, I'm probably going to do a little bit of tweaking. Try and do a bit of testing as well before I launch it. But definitely by tomorrow, I'll have this uploaded on my H channel. And if you don't follow me on Facebook, please go and follow me on Facebook. I'm going to post a link over on that as well. And just to end the stream off, I'm going to say I have a Patreon. If anybody wants to donate to that Patreon, feel free. If you've learned something, I'm more than happy to accept that cash. And we got the congratulations falling through now. Beautiful, beautiful. So I hope you had fun. I hope you've learned something. I know it's been a little bit choppy because this is my first live stream. I don't think I've done too bad. There's not been many awkward silences. Yeah, if you want to do this more often, guys, just let me know. I've had fun. It gives me something to do while we're in lockdown, doesn't it? I mean, I'm sat at home, bored, a lot of the time. This has been fun. Bit of preparation, a couple of days preparation for me, and we've actually had a good time. Got a good game out. Said good. Again, it's not going to win Game of the Year, but it works. We've got some advanced techniques in there as well. We've got some character movements, some basic AI. We've got an automated map generator. We can add in maps now in seconds. We can just draw a new one in Aseprite. Bang, we're done. But yeah, I really hope you've enjoyed it, guys. I hope it's not been a waste of my time, and I don't think it's been a waste of anybody else's time as well. We've still retained, pretty much looking like it, pretty much retained everybody on the way through, or we've not really had much fluctuation, so I think you guys have enjoyed it as well. But right now, I think what I need to do, I need to walk down to the shop and get myself some beers. So I'm going to end the stream now. Thank you so much for watching this. Thank you so much if you've been here from the start. Follow me on Facebook, Instagram. I've got a Patreon if you want to give me a quid. I don't know. You might have learned something. It might be worth £1 to you. If not, who cares? It's down to you. Also, subscribe to me on YouTube if you're not already. I know I got 1 subscriber while I was doing this, so that was good. I enjoyed that. Alright. That is it. And now I'm going to end the stream with a fancy little fade out. Watch this. How good was that?